Manisha here. How are you all? I thought everyone is fine and everything is good. If you like my channel, please subscribe it and click the bell button to receive every video I put and like the video. If there is any doubt or suggestion, come to the comment box. Today I discuss about the conservation laws in particle world. I already discussed lepton number, baryon number and done some problems. The link to those are given in the description box. Don't forget to see that. Today we discuss about isospin and strangeness number. Okay, let's move to the video. Isospin quantum number, capital I. Isospin is similar to spin in spin dynamics. Okay, let me discuss more. Elementary particles are classified into three groups: leptons, hadrons and field quanta. Leptons, hadrons and field quanta. Field quantum is the flux which is radiated through the interaction. Here I wrote only leptons and hadrons. Okay, leptons have no isospin and hadrons have isospin. In spin dynamics, spin or multiplicity is given as 2s plus 1. Similarly, in the isospin, m multiplicity or number of the particles in a group is given as m is equal to 2i plus 1, where m is the multiplicity. M is multiplicity. Already told lepton have no isospin and hadron have isospin. Let's take an example of two particle group, proton and neutron. It's a two particle group, that means m is equal to 2, which is equal to 2i plus 1. That means 2i equal to 1 and I is equal to 1 by 2. Next we take a one particle group, lambda naught, which has multiplicity is 1, that means 1 is equal to 2i plus 1, that means I is equal to 0. Let us consider the case of three particle group, pi meson, pi plus, pi naught, pi no, minus. There are three particles, that is multiplicity is 3, that means 3 is equal to 2i plus 1, that means 2i is equal to 2, that means I equal to 1. If we take four particle group, that means delta plus plus, delta plus, delta naught, delta minus, there is particle, that means multiplicity is 4, that means 4 is equal to 2i plus 1, that means 2i is equal to 3, I is equal to 3 by 2. That means if the group contain only one particle, then I is 0. If the group contain two particles, I is half. If the group contain three particles, I is 1. If the group contain four particles, I is 3 by 2. Okay. Next conservation law is third component of isospin. Third component of isospin. I already told isospin is similar to spin in the case of spin dynamics. Then in spin dynamics, if S is equal to half, then multiplicity 2s plus 1 is equal to 2 into half, that means 1 plus 1 is 2. That means if we draw a graph in straight direction. There is two projections of electron in half and minus half. That means ms values are half and minus half. Similarly for isospin also. That means number of projection is 2i plus 1. That means for a two group, that means multiplicity is 2, proton and neutron, I is given as half, then 2i plus 1 is equal to 2 into half, that means 1 plus 1 is 2. That means there are two projections along the z axis. Plus half and minus half. If we look at this graph, we identify that the isospin varies from minus psi to plus psi. I3 is given as the charge of the particle is denoted as Q minus Q bar, where Q bar is the average charge of the group. Once again, I3 is denoted as Q minus Q bar, where Q is the charge of the particle and Q bar is the average charge. Let us consider an example. Again, two group, proton, neutron, two elements group, proton, neutron. This have average charge. Proton have charge 1 and neutron have charge 0. Then average is half. Then we write I3 values. I3 is given as Q minus Q bar. That means P is equal to Q value is 1 minus half, which is equal to half, 0 minus half, which is equal to minus half. Okay. Once again, let us consider 3 element group, pi plus, pi minus, pi naught. Here average charge is equal to Q bar is pi plus have charge 1, pi minus have charge minus 1 and pi naught have charge 0. Then the average is 1 minus 1 plus 0 divided by 3. Okay, 1 minus 1 is 0, 0 by 3 is 0. Here I3 values I written. I3 is equal to 1 minus 0 is 1, minus 1 minus 0 is minus 1, 0. Okay. One more problem. Let's consider the four element group, delta plus plus, delta plus, delta naught, delta minus. Here average charge is Q bar is equal to, there are four particles and 4 charges. First one have charge 2, second one have 1, 0, minus 1. Average of these two is 0 and this one is 2, that means 2 by 4, which is equal to half. Okay, then I3 values are 2 minus half is 3 by 2, 1 minus half is half, 0 minus half is minus half, minus 1 minus half is minus 3 by 2. If you look at these charges, since I3 values are from minus I to plus I, that means here 4 group contain I3 values 3 by 2. That means here I3 values changes from minus I to plus I. If higher the charge, then higher will be the I3. If the lower the charge, lower will be the I3. Okay. Let us discuss all the particle and I and I3 values together. First one is category is mesons and I3. In meson group there are 3 types of particles: pi meson, k meson and eta meson. Pi meson, first thing is pi meson. Pi meson contain 3 particles: pi plus, pi naught, pi minus, which have I value. Here multiplicity is 3. Then 3 is equal to 2i plus 1. 2i is equal to 2. Then I equal to 1. 1, 1, 1. All the particles in a group have same I value. Okay. Then I3 changes from minus I to plus I. That means plus 1 we already told higher the I3, then higher the charge. Okay, this one is higher charge, that means higher I3. 1, 0, minus 1. Okay. Next is k meson. K plus and k naught. Here there are 2 particles, that means 2i plus 1 is 2, that means 2i is equal to 1, that means I is equal to half. Then I3 values ranges from minus I to plus I, that means minus, higher the charge, higher the I3, that means half minus half. Next is antiparticle of k meson, that means k minus and k naught. Here there are 2 particles, that means I values are half and half. Here the higher charge is 0, that means here half minus half. Next is eta meson. Here there is only 1 particle, that means 2i plus 1 is 1, 2i is 0, that means I value is 0 and only 1 particle which have I3 is 0. Okay. Next is spin half baryon. Spin half baryon I3. Okay, particles. First is proton, neutron. 2 particles are there, then I3 changes, I is half. Proton have higher charge, which that means I3 is half, and neutron have minus half. Next is delta naught, only 1 particle, that means 0, 0. Sigma plus, sigma naught, sigma minus, 3 particles, that means 1. Higher the charge is sigma plus, that means 1, 0, minus 1. Next is cascade group, cascade 0 and cascade minus. 2 particle group, that means half and half. This one is more charge, that means half, and this is minus half. Okay. Next is spin 3 by 2 group. Spin 3 by 2 baryons. I3. First is delta plus plus, delta plus, delta naught, delta minus. 3 particles are there, that means 3 by 2, 3 by 2, 3 by 2 and 3 by 2. More charge is delta plus plus, that means 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2. Next is sigma star plus, sigma star 0, sigma star minus. 3 particles are there, then I is 1, 1, 1, and this have more charge, that means 1 0 minus 1. Next is cascade group, cascade star 0, cascade star minus. There are two particles, that means I value is half. This have more charge, that means half minus half. Next is omega minus. Only one particle, that means I is 0, I3 is 0. The last topic is strangeness quantum number, which is the fifth of the conservation laws. Strangeness quantum number. Strangeness quantum number. It is denoted as capital S. It indicates the strange behavior of hadrons. Elementary particles are, I explain more. Elementary particles are divided into leptons and hadrons. Leptons are weakly interacting and hadrons are strong interacting. But some hadrons, K meson, delta naught, sigma, cascade and omega minus, these are hyperons which have hypercharge Y is equal to B plus S. These are formed through strong interaction, and decay through weak. These particles are called strange particles. According to Gell-Mann-Nishijima formula, Q is given as I3 plus B plus S by 2, where I3 is the third component of isospin, B is baryon number, S is strangeness number. Okay. Let's write all the strange particles. First is K meson, that means K plus and K naught. We have Q is equal to I3 plus B plus S by 2. Then we have to find out the S, strangeness number. Okay. Here Q, charge is 1, which is equal to I3, means here I3 is 2 particles are there. I3 is half plus baryon, it is not a baryon, that means 0 plus S by 2. That means S by 2 is half, then S is equal to 1. Similarly, also Q is equal to 0. 0 is equal to half plus 0 plus S by 2. That means S is equal to 1. That is, S is same for all the particles in a group. Okay, next. Antiparticles of K meson, K naught. That means only one is enough. That means Q is equal to minus 1. Minus 1 is equal to 2 particles are there. That means I3 is half minus half plus 0 plus S by 2. That means minus 1 plus half is minus half. S is minus 1. Next is delta naught. Q equal to 0 equal to I3 value is 0 because there is only one particle. It is a baryon, that means 1 plus S by 2. That is, S is equal to minus 1. Next is sigma group, sigma plus, sigma naught, sigma minus. There are we only one particle is needed, that means 1 is equal to, here I3 value is also 1 plus, it's a baryon, that means 1 that means plus S by 2. Okay, that is, then S is equal to 1 minus 1 is 0, S is equal to minus 1. Next is cascade group, sigma naught, sigma minus, charge is 0, 0 equal to, there are 2 particles in a group, that means half, plus, this is a baryon with a baryon number 1 plus S by 2, that means minus 1 by 2, minus 1 by 2 into 2 is minus 1, this minus is minus 2, S is equal to minus 2. Next is omega minus, charge is minus 1 is equal to, it's only one particle, that means I3 value is 0, 0 plus 1 plus S. In this video I discussed about the conservation laws in particle physics. The first law is lepton number. In lepton number, all leptons are denoted as, for lepton number is 1 and antileptons are minus 1, and for others it is 0. Next is baryon number. For baryon number, all baryons have 1 and antibaryons have minus 1 and others have 0. Next is isospin. Isospin is given as from the multiplicity m is equal to 2i plus 1. From there we calculate I. If there are only one particle, then I value is 0. 2 particles, I value is half. 3 particles, I value is 1. 4 particles, I value is 3 by 2. 3 by 2. Okay. Next is third component of isospin. That means it is given as I3 is equal to Q minus Q bar. That means charge minus average charge. If the more charges are in the particle, then I3 will be more. Okay. Next is strangeness number. If the particle formed through strong interaction and decay through weak interaction, they are called strange particles. There are 5 strange particles are there: K meson and delta naught, omega family and sigma family, cascade family. Their values are given as K meson have S equal to 1, anti meson have S is equal to minus 1, delta naught have S equal to minus 1, sigma have S equal to minus 1, cascade have S equal to minus 2, omega have S equal to minus 3. Okay, let's wind up this portion. See you in the next video.